Welcome to our next lesson, where this lesson is on squares and square roots. So in this lesson, we're going to work on how to find the squares and square roots of whole numbers. So the first question we have to think about is how can we tell whether a number is a square number? So we encounter questions that ask us to list the square numbers or to just find a square number. So the first method we can look at is if we can find a division sentence for a number so that the quotient, change my color, the quotient is equal to the divisor, then the number is a square number. The number is a square number. So what does that look like? Well, if we have a division sentence, so we're going to say, let's say the number is 16. If I have 16 and I divide that by 4, and my answer to that is 4, then my first number in a division sentence is called the dividend. So if I have the dividend, and I'm dividing that by a divisor, and my quotient is the answer to a division sentence. So in this one, the divisor is equal to the quotient, so therefore it is a square number. Let's look at another example. So if I have the number, let's say 18, and I take 18 and I want to divide that by, maybe I divide that by 6. 18 divided by 6 equals 3. And in this case, is the divisor equal to the quotient? Nope, it's not. So this one is not a square number. And it's also a situation that if 18 has more than just that factor, I can go 18 divided by 2. 18 divided by 2 equals 9. Again, 2 and 9 are not equal. So this again is not an example of a square number. It's a square number. Another method we can use is a factoring method. So remember that the factors of a number occur in pairs. So when I'm finding the factors of a number, I'm asking myself what two numbers, when I multiply them together, give me the number I'm looking for. So if I think about the number 16, what are the factors of 16? Well, I can have 1 times 16, 1 times 16. So that's what this box is representing. I have 1 on this side, 16 represented here, and the area inside of this box is 16 units squared. So 1 times 16 is a factor of 16. I also have 2 times 8. So 2 on this side, 8 on this side, and an area of 16 unit squares on the inside there. So that's another factor. 2 and 8 is a factor of 16. And I can also have 4 times 4. That is also a factor of 16, because 4 times 4 gives me 16 units. So those are all factors of 16. And if we list those factors, I have 1 and 2 and 4, and I'm not going to write a 4 again because I've already got a 4 written there. So I don't need to write it again, but I can continue on. I have 8 and 16. So if I look at this list of factors, there are 1, 2, 3, 4, 5 factors there. So 5 factors, running out of space. 5 factors is an odd number. And your rule here is that if the number of factors that you have is odd, then you have a square number. So 16 again has 5 factors. 5 is an odd number. So this square has a side length of 4. So that means that 4 is a square root of 16. So we can write a square root like this. This is a symbol we use for a square root. Equals square. So the square rooting a number and figuring out what the square of a number are actually inverse operations. So with this square, I have 4 and 4, which would make 16 at the center for the area in the middle. And if I didn't know the length of the side, I could figure that out by taking the square root of a number. So as I mentioned, when we square a number and square root a number, these are what we call inverse operation. And what this means is that they undo each other. So for example, if we are trying to find the square of 4, 4 squared is equal to 4 times 4, which equals 16. But if I want to find the square root of 16, what this means is that I'm trying to figure out what two numbers, when I multiply them together, equals 16. Well, the two numbers that multiply together that are the same as one another that equal 16 would be 4 times 4. So your answer for the square root of 16 is 4. So let's look at some examples of this. When we're finding the square of each number. This is review from our last lesson. So if 5 squared, that equals 5 times 5. 5 times 5 is 25. If I think about 15, if I'm squaring 15, 15 squared, we write with an exponent. So that would be 15 times 15. And 15 times 15 is 225. So the square of each of these numbers, again, is taking the number and multiplying by itself. But when we're finding the square root, we're doing the opposite operation, or actually the inverse of it. And when you're taking the square root of a number, you're actually usually having a larger number that you're dealing with. When we're finding the square root of a number, we write it with our square root symbol out in front. And we ask ourselves, what two numbers that are the same can I multiply together to find the answer that I'm looking for? In this case, 64. Together to find 64. Okay, so if we think about our multiplication tables, if we have a square, and if this square, is not actually it, but if this square had 64 units on the inside, I recognize that this one does not actually, but we have to think about what two numbers, what would the side lengths be to equal 64? Well, 8 times 8 would equal 64. So the square root of 64 is 8. So the last thing we're going to do is use one of the tricks I told you earlier to determine whether a number is a square or not. So if we think about the number 136, the question asks us to use factors to determine whether 136 is a square number. So what we need to do is list the factors of 136. So if I have 1 times 136, well, that equals 136. If I go 2 times 68, that also equals 136. If I go 3 times something, it won't work, but I can go 4 times 34. That gives me 136. 5 times something won't produce 136. 6 times something won't produce 136. But 8 times 17 equals 136. And so then these would be my factors. So we can count them up. How many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. The answer that I have here, is it even or is it odd? Even or odd? Well, I counted up 8 factors, so it is an even number. So if I think about the rule back from the start of this lesson, there has to be an odd number of factors in order for it to be considered a square number. So 136 is not a square number. Great work. Thanks for following along with me. I will post the this into the Google Classroom for you. Thanks, guys. Have a good night.